The standard is 8.EE.1, know and apply the properties of integer exponents. And our essential statement says, I can use the power of a power and the zero exponent properties. Okay, so the first rule we have is right here. It's the power of a power. If you have any base a to the power of m in parentheses raised to the power of n, that actually equals your base a to the power of m times n. Here's our first example. If you have 8 to the power of 3 in parentheses to the power of 4, what does this really mean? So we're going to do it the long ways. What does the long way mean? Well, it tells you why something works, why the rule works. So really, if you think about it, remember what exponents mean. Exponent is when you multiply the base however many times the exponent tells you to do so. So in this case, our exponent is 4, which means you're going to take your quantity that's in the parentheses and multiply it 4 times. So I wrote it out for you. 8 to the power of 3 times 8 to the power of 3 times 8 to the power of 3 and times 8 to the power of 3 4 times. If you use the rule we learned in our last lesson, you know that what you have to do with these exponents is just add them up. So here I have 3/8, here I have 3/8, and in total I have 12/8, 8 to the power of 12. Why does the power of a power rule work? This is why it works, because if you think about it, 3 times 4 is also 12. Okay, we'll do one more example. Here we have 4 to the power of 5 in parentheses to the power of 7, and that actually equals 4 to the power of 5 times 7, which is 35. Okay, so that's our final answer. What we're doing here is we're simplifying exponential expressions. I don't want you to actually give me what this number is. All I need to know is what the simplified exponential expression would be. All right, moving on. Here we have the product of a power. So this rule actually uses this rule and combines it with something else. If you notice, we have two different bases now, base A and base B. You're multiplying those two different bases to the power of m. What we're doing here is we're actually distributing the exponent to everything inside of the parentheses. So that would equal a to the power of m times b to the power of m. And on the left-hand side here, I wrote, for this rule, you distribute the exponents, okay? If you think about it, distributing means you multiply. All right, so here's our first example. We have 6j in parentheses to the power of 4, okay? 6 is a different base, j is a different base. If I ask you, what is the exponent on this 6? Well, you will tell me it's 1, because when there is no seen exponent, the exponent is 1. Same here for the j. And then we use our rule that we learned up here to solve this. When I distribute, I put a 4 here. 1 times 4 is 4. When I distribute, 1 times 4 is 4. Therefore, when I write this down, my answer is 6 to the power of 4 times j to the power of 4. When a number and a variable are right next to each other, that means you're multiplying that number and variable. Okay, one last example here. Okay, here we have 2z to the power of 3, all in parentheses, to the power of 5. Okay, this is a teachable moment here real quick. I put a slash through my z's. This is so that you don't confuse my z's with the number 2. I suggest that you do that as well. Okay, so here on this 2, we actually have an exponent of 1 because it's not seen. So if it's not seen, the exponent is 1. And then I'll go ahead and distribute the exponent on the outside of my parentheses with everything on the inside of my parentheses. So really, I have 1 times 5. 1 times 5 is 5. So my base is 2 to the power of 5 times z to the power of 15, because 3 times 5 is 15. Okay, I'm using the product of a power rule. It means when you distribute the exponents, you have to multiply with everything inside. So the exponents get multiplied. Okay, and lastly, here we have the zero exponent property. that states that any base a to the power of 0 equals 1. I wasn't going to do this, but I'm going to go ahead and show you why this works. If we have an example like 2 to the power of 3 over 2 to the power of 3, okay? If we used our rule from the last lesson, this is the quotient property that states you can take the top exponent and subtract the bottom exponent. 3 minus 3 is actually 0, and you're like, okay, well, what do I do now? Well, anything to the power of 0 equals 1, and this is why it works. 2 to the power of 3, when I write it out, is actually 2 times 2 times 2, okay? And again, 2 to the power of 3 is also 2 times 2 times 2. And when I simplify this fraction, 2 over 2 equals 1, 2 over 2 equals 1, and 2 over 2 equals 1. And 1 times 1 times 1 is just 1. And this works for any number at all. So if I asked you, what is 1 million to the power of 0? Your answer to me would be 1. Okay? That's our lesson for today. If you have any questions, please let me know.